All right, so for those of you that joined the first session, welcome back, and thank you for joining that session. For those of you that may have missed the first session, later in this session, I'll share a link in the chat to the first session, but you guys can navigate to Codecademy's YouTube channel. There is a recording of the first session on their channel there that you can access. So today is going to be a continuation off of that first part. We are going to do a little bit of review. So if you did miss the first session, don't worry. We'll cover a few of the concepts, some of the important things that we covered during the first session. And then we'll jump into today's session. We're going to be getting a little bit more on Git. All right, so before we begin, I always have this slide in all of my events that I do with Codecademy. I think there's a few important call outs here. The first one is to be brave and be vulnerable. That kind of goes around. If you have a question, don't feel afraid to ask a question. No question is silly, especially when you're learning something, right? You don't know what you don't know. Every single one of us has to start from some place, and when we lean into that and we help each other out, all of us can grow, and hopefully by the end of the session we'll learn something. Everybody here in the session, keep things appropriate in the chats. Get engaged. You guys are engaged by showing up here today, so I thank you for that as well. And then, of course, let's have some fun, right? Learning should be fun. These events should be fun. We're going to be doing some demo and some hands-on pieces as well, so you guys will get an opportunity to actually play around with Git. So if you don't have your VS Code or whatever IDE you might like to use open already, feel free to get that started. We are going to be doing some hands-on stuff throughout the session. And if you guys have heard of the demo gods at all, it's something I like to kind of bring up within the industry. It's kind of a joke around every time we do a demo or we try to show something, whatever could go wrong might go wrong. And so hopefully they're smiling upon us today and we'll have a successful session. Today's agenda, so again, kind of like what I mentioned, we're going to do a quick review of Git and GitHub, what they are, some of the common terms that we're going to be using throughout the sessions. We're going to talk about how we connect with GitHub. Specifically, we're going to kind of look a little bit more into repositories. We're going to be looking at connecting a remote repository to a local one, vice versa, connecting a repository that we have locally to a repo that we'll create within GitHub. So if you're not logged into your GitHub account, right now is a great time to do so as well if you have one. We're going to talk about cloning, forking, and pushing, the differences between those three different actions, especially when we're creating repositories. That's a question that I hear common with people that are new to Git, so we're going to dive into that a little bit. Once we review all that content, we're going to jump into branching. We're going to talk about what branching is more in depth. We're going to get some experience with creating different branches. And then in that, we're going to get some more experience with merging commits between different branches as well. When we do that merging, we're going to get an opportunity to see some of the conflicts that might arise if we have changes that are targeting the same file. So we'll get some hands-on experience with that. And then throughout the session, you guys are going to see that when we create branches, when we do merges, when we create commits, you're going to see how the commit history kind of evolves over time as well. That's something really interesting and very important to learn when you're using Git. Don't mind my awkward silences throughout the session as I take some water or whatnot. I will also pause for questions throughout the session if I see any. I do have the chat open. So if I see questions pop in, I will do my best to answer them, but I'll try to make some time for that throughout the session as well. All right, so let's get started. Quickly reviewing last session. So we dove into Git. We talked a little bit about what Git was. We talked about what GitHub was. And so some of the terms that we reviewed are repository. A repository, if you guys aren't aware, you can kind of think of those as like a folder for your code base. There are two types for isolated environments where we can safely experiment with new code features, fixes, etc. So you can kind of think about if you have like a main production branch where all the code that is actually being hosted on a server that your end users are connected for your end users. And, if you work for a business, that could have some negative effects as well, right? The server might not be available. The experience for the customer might be damaged. And so there's a few things you want to be aware of there. So With branching, we're able to create different environments that basically copying the same code. We're able to make adjustments to that code without impacting real environments, so to say. So that's one of the powers of using branches, but more on that today. We reviewed what commits were. Commits essentially are just saved sets of changes with a unique identifier representing them. A commit can represent changes made to one file, 3 files, 10 files, however many files you made changes to. When you take changes that you make within your working area, so you see that term there, there's a concept of a working area and a staging area. When you're working within your IDE, you're starting within a working area, you're making changes to files. As you save those changes to those files, what you can do is you can stage them. Think of it two-stage. You stage those changes with what's known as your staging area. If you're familiar with some of the commands like git status, that shows you the status or the difference, so to say, between your working area and staging area. Are there new files that have been added? Are there new changes that have been picked up on? And so when you put changes into a staging area, you're able to take all those changes and form a commit for those, and that's just to save those changes to your code base, so to say. And then in that, one of the big key takeaways of the first session for anybody that's either viewed or was there, you'll remember, so we wanted to really differentiate between the differences between Git and GitHub. So Git is a tool that runs on your computer, or it's a software, right? It's something that runs on your computer locally to track changes to your code over time, kind of like saving versions of your work or a video game as you make progress, right? Whereas in GitHub, something completely separate, GitHub is a cloud-based repository hosting service that stores those versions online and gives you additional tools. Tools to collaborate with others, review changes. Pull requests are something that facilitate the merging or the proposal, if you will, of taking code from one branch and moving it to another branch. The PR or the pull request kind of facilitates that process. It enables people on the same team or other teams to review your code and leave comments. Are a really powerful tool, especially in a team collaboration environment. So now that we understand a little bit about what Git is and what GitHub is and the difference between them, today's session, as we kind of talked about earlier, is going to be diving more into what repositories are, differentiating between remote and local repositories. We'll dive further into branches, and then we'll do some merging and some conflict resolution to wrap up the session. So diving deeper into repositories. A remote repo, so you see on the left-hand side of the screen here, remote repo with GitHub lives in the cloud, like on GitHub, and acts as a shared source of truth. It stores the latest accepted changes and is where team members push their updates and pull new changes, as if like your Google Drive in some ways, right? So if you guys are familiar with Google or Microsoft Office Online, those suites of tools, if you open up a Google Doc or a Google Sheets, right, you can see who's on that document, you can see who's editing it live, but you can also work on those offline, right? And then you can, when you connect back to a network or the internet, you can push those changes that you made to those documents while offline to that shared source of truth. So you can kind of think of like the remote repo as like the Google Drive, where all the documents that a team shares and works on collaboratively, they live in the cloud and they're accessible there and they can be distributed from there, right? If you guys remember from the first session, one of the big things about Git was its distributive nature. And so when I say it's distributive nature, what I mean by that is, really in a nutshell, there's one same repository and get a copy of the code and the commit history associated with it. So that's what I mean when I say Git's distributive nature. Having a remote repo in GitHub really amplifies that, if you will. So on the opposite end, we have a local repo, and the local repo is what lives locally on our computer. It contains our personal working copy of the code base, including any commits and branches and changes that we've made on the code base that may or may not be shared yet, right? So when you create a local repository, which you'll see later in the session, and you create branches or you add additional commits to those new branches that you create, until you actually push that stuff, you'll see the action here from going from local to remote, you're pushing. Going from remote to local, you're either cloning or you're pulling. But if you have something locally and you have yet to push it to GitHub, GitHub has no knowledge of that. They're not going to see any of those new branches, any of those new commits, anything. You need to physically push that code to GitHub in order for that stuff to show there. So there is a very distinct isolation between the two, if you will. I'll pause there real quickly because I want to make sure that everybody understands the difference between a remote repository and a local repository. Does anybody have any questions off the top of their minds? I don't see any in the chat, but I'll just want to pause real quickly. Again, a repo lives in GitHub. The remote repo lives in GitHub. Local repo lives locally on our computer. All right, doesn't look like we have anything yet, so let's continue. All right, so when we talk about repos, right, we've got the three different words here on the screen. We've got cloning, forking, and pushing. Cloning, starting on the left here, cloning is when you copy a remote repository to your local machine, creating a fully functional local Git repository. You can make changes, you can commit locally, and you can push to the same remote if you have the permission to do so. The key takeaway with cloning a repository is that when you're cloning a repo, that repo that you cloned from, that's going to be your remote, right? So if you have, let's just say you go to a GitHub repository called testing, and you clone that testing repository. What you're doing is you're taking a copy from GitHub and you're making a copy of that repo on your local machine. The big difference. Let's talk about forking next, and then I'll talk about the difference between the two. Forking is essentially almost the same thing. You are still copying someone else's repository into your GitHub account locally. You're still copying someone else's repository. The big difference between forking and cloning, though, is that if you're working on like the same development team, you're going to be cloning because you're working within the same repository and you're sharing the same remote when you're working on your machine. Forking is a little bit different where even though you're still making a copy of a repository, you're making your own distinct copy of the repository. And you actually have two remotes here. And again, think when I say a remote, I'm talking about a repository that lives in GitHub from the perspective of working on your own machine, right? So when you're working on a repository locally that you've forked, you have your remote repository, which is the one that you forked, the one that you created on your GitHub. But you also have this other remote called upstream. And this upstream remote is going to be the original project that you forked. And the primary purpose for this setup here is that when you fork a repository, what's I think a common use case here is any open source project. You may fork the repository that has that open source code. You may want to make some changes. Maybe you noticed a bug and you wanted to add a fix, or you had an idea for a feature and you wanted to add that into the open source project. What you would do is you would fork that project, add your changes, and you can actually open a PR from your repository back to that upstream repository. And then the original creators of that repo or any contributors of that repo that have the permission to do so, they can review your PR and actually accept the code from your forked repository into their original repository, if that makes sense. So really, again, the biggest difference between cloning and forking is cloning. You're creating a copy of the same project. Everybody's working on the same project. If everybody on this call cloned the same remote repository, even though all of us would be working within our local repository on our own machine, when we go to push those code changes back to GitHub, they'd be going to the same repository. Whereas again, when you fork a repository, you're creating your own distinct copy of it, but you still have that upstream remote, if you will, in order to send code from your repository back to the original that you forked. Hopefully I've described that enough to make sense. I do hear sometimes people have questions on differences between the two, when to use one or the other. So hopefully that clears things up a little bit, but if you have any questions, please feel free to throw those in there. I do see into the chat per se, I do see one question real quick, difference between cloning and pulling. So when you clone a repository, that's the That's the first action that you need to take in order to get a copy of the repository. But let's say once you've cloned the repository and you have all the code locally and you're making changes to it, let's say you have like a shared develop branch that's all the code that everybody wants to test or all the new features that people want to test, they push the code there first, including yourself. If there's new code that lives on that branch that you don't have within your local repository that you need before you push to GitHub, you would use an operation called git pull. Git pull is to pull information from GitHub for a specific branch. That way you just have the latest copies of it. Because you can think that if you have a local repository and let's say you don't update your local repository for 3-4 weeks, and other people have made changes to that remote repository since the last time you pulled your latest copy of it or cloned it, there's going to be code that lives in GitHub that doesn't live within your local repository. And so you're going to need to use an operation like git pull to pull that information locally so that you have it saved. Hopefully that helps to answer that question. That's a good one. And thank you for asking. So pulling and pushing is kind of the opposite of pulling. When you use I want to say one thing real quickly when it comes to git pushing. When I say that when I use this term here, I'm meaning you're initializing a new repository. But when you push as well, that could also be you just have code changes within a branch and you want to push those to GitHub. There's two different actions there. You're either pushing code to GitHub, or you have a repository locally. Let's say you guys have been working on a project for the last couple of weeks, or maybe you're new to coding and you just started with Codecademy this year. And since learning in January, you have a project locally that you want to put in GitHub and share with other people. You can create a repository locally within a directory that you already have created, and you can push that code to a repository on GitHub that's empty and ready and willing to accept it. So that's what I mean when we're pushing. You can create a repository on GitHub that's completely empty, and as long as you have code locally, you can create that repository there and push it, and you guys will see an example of that in today's session. When you do that, though, you are creating that new remote repository. That remote repository, if you allow, because a remote repository can be public or it can be private. Sometimes you might want to keep a project private and just share it amongst some friends or some colleagues. Other times you might want to leave something completely public and allow anybody to take a look at it. But when you create a repository, you're essentially allowing that repository to be cloned or be forked by others if you allow that access. So I'll pause there real quickly. Does anybody have any questions on cloning, forking, or pushing, or the differences between the three? Okay.
It doesn't look like it, Nick.
All right, let's continue. All right, so here we're going to be getting a little hands-on. We're going to be doing two different sessions, or not two different sessions, two different examples, or scenarios rather. We're going to do a local to remote setup, and then we're going to do a remote to local setup. And hopefully after reviewing those, you guys will feel more comfortable with creating and managing your own repositories as well.
Oh,
So
Nick,
let's,
sorry, but
yeah.
we do have a question from Karen. Karen asks, what about the limbo state
Yes.
stash?
Karen, come back for session 3, please. Stashing is a topic that we're going to be covering in session 3. Great question, though. All right, so we're going to first scenario for today. We're going to set up a local repository. We're going to push it to remote. So a use case here would be you have a project on your machine that you want to store or share on GitHub, right? And as I mentioned before, this new repository can either be private to you or you can share it, be public with others. So to practice this, again, we're going to set up a local repository. We're going to put one commit in that repository, and then we're going to use these commands on the right to push that project to our GitHub account. So I'm going to exit from my presentation real quick, because in order to set up, you have to have the repository exist in GitHub, period. Whether it's pushing from local to remote or copying something from remote to local, it's more intuitive, as of course, if you're copying something from remote to local, it must exist on GitHub. But in order to push a local repository to GitHub as well, the remote repository still needs to exist. So I'm going to go back. I'm going to exit out of here. I'm going to go over to my GitHub account here. I'm going to go to my repositories. and I'm just going to create new, and we're going to call it testing. We'll say local testing. Make sure that's available. It is. I'll just make this private for now. Let's go ahead and create the repository. GitHub is really useful in the fact that when you create a repository, some of the commands that I just had on the screen, they actually give you those commands right here within the user interface as well when you go to create a new repository. So for this scenario, we're going to create a local repository and we're going to push that code up to GitHub. So I'm going to want this the second option here where it says or push an existing repository from the command line. You'll notice that I have my URL here for my repository, but all these other commands right here are going to be the same as to what I just had within here. You see git remote add origin, repository URL. Then you've got your branch main. This just renames your branch that you're on to main if one hasn't been provided otherwise. This is a very common naming convention for your main branch. So using this command just renames it to main if it's not already main. And then this command git push origin to main. This takes all the code within your repository and all the commits that you have, not the code, but the commits that you've at least associated to the repository, and it pushes all those to your origin main branch within GitHub, excuse me. So let's go ahead and see that in action. We've got our repository here. I'm going to grab my URL here. Copy that. Let's open up VS Code. Okay, so I'm in my VS Code right now. I will zoom in one more just to make sure everybody can see that. I am starting in an empty directory right now. I do need to go into one of the directories I already created, which is my local to remote scenario. If I do something like git status, as you guys might recall this from the first session, it's not going to do anything because I don't have a Git repository created right now. So if you guys recall from the first session, in order to create a repository, we need to use the command git init. This just means git initialize. That's going to go ahead and initialize that empty Git repository for me. So I'm in this local to remote directory right here. What I'm going to do is I'm just going to create a commit. I'm going to make a new file. We're going to do a README. I like to just use one file and use very simple commits when I do these demos. I feel simplifying the content it allows everybody to truly understand like the root of how things actually work. You're able to further enhance your learning from there. I feel if you try to bite on too much at first, it can be very daunting, confusing, and it's not a good way to learn. So I try to keep things pretty simple here. So what we're going to do is we're going to start with just one README file. I'm going to add a header level 1, and I'm just going to say, welcome to my test, and we'll just save that. Going back into my terminal, if I use that same command of git status, we're going to notice that we have an untracked README file, which is to be expected. I'm going to go ahead and add that file. If I use git status one more time, we'll be able to see that that new file is now being tracked and it's been staged, right? If we went back and we think about the working area and the staging area, back when I did this git status, README was in my working area. It had not yet been tracked and it had not been staged for commit. By using that git add README command, what I've actually done is I've added that README from my working area to my staging area. And then to make a commit, all I need to do is do git commit -m, and we'll just say initial commit. Nothing too fancy here. So if I do a clear, if I do a git log, you guys can see that I have my initial commit here. Here's the commit hash. We have a commit history on this repository. If I go back to my GitHub, you can see that no code still sits here. So let's go ahead and use these commands here. We're going to use the first one, which is git remote add. And again, this is what you would do if you just have a repository locally that has not yet been pushed to GitHub or associated with one. If I use this command right here, actually, you know what? I'm gonna go back one because what I want to do is do git remote, and I believe -v. If I do git remote -v, what that command does is it's actually showing or listing what I might have for remote repositories. The fact that it doesn't say anything here after I press enter proves that I don't have anything currently, okay? So once I use this command and I go back to that git remote v, you can now see that I have my remote set up and I have my origin for fetch and push. Fetch is to pull, push is to push. So when I say that fetch to pull, I'm taking code from Git. So now that that's been set up, again, just using the tools that are provided to us, go back to GitHub. Again, they offer these really nice directions. You can copy this next one. Again, this one's just to rename your main branch to main. Git push -u origin main. So what this is going to do is you're going to see that some of the objects, it's counting them, it's writing them to GitHub. No errors were thrown, everything looks great. So if I go back to my GitHub and I click refresh, I'm not going to see this anymore. I'm going to see my README that says welcome to my test. And if you guys recall, that was the level 1 heading that we put into the README. It does say dummy user because I just have a test email associated with my account for the sake of this demo. Otherwise, you probably would see your name here as the person associated to that commit. But that's an overview of how you would create a local repository and push it to GitHub. So user, we're going to create a new repository. And this one, we're going to say remote testing. Let's still make this one private. The difference with this scenario is I'm going to add a README. And the reason I'm adding a README is because I want something to already exist on this remote repository before I go and clone it, because I want to make sure that when I clone it, whatever might be in that README file on GitHub, I want that to actually be shown within my VS Code file as well. So let's go ahead and create that repository. You'll see that we have a README. It's got this remote underscore testing level 1 header. That's just the default. That's fine. If you have a repository on GitHub that you want to pull locally, all you need to do is go here, copy this HTTPS. You can use a GitHub CLI. The CLI is a pretty neat tool that's going to be out of scope for the session. You can also use SSH keys if you're familiar with those as well. But I think one of the most, probably the primary, if most often travel path is just copying the, let's go back to your VS Code. And I'm going to clear my screen. I'm going to step back out of my local to remote repository, and I'm going to change directories into my remote to local repository. And again, just to show that I don't have a Git repository here, if I do git status, it'll be fatal. There is not a Git repository, and that's fine. But there will be after I do git clone, provide that URL. And you can see that this is cloning into remote testing. There was a total of 3 objects being packed down. That's fine. Let's see what we got. One thing to keep in mind when you clone or you pull something from GitHub locally, right? One thing to keep in mind here is even though I'm in my remote to local, if I list the contents of this directory right now, one might expect to see that README file. We're not going to see it though, because when you clone, all you're doing is cloning another directory that has the same name as your repository. The repository code lives within that directory. So if I actually did another git status at the level I'm at right now, you can see that it's fatal because I'm not within a Git repository. In order to get there, I actually need to change directories into the repository that I cloned. So once I do that, I'll clear my screen. You can see that I'm in that remote to local
Hey Nick,
directory that I
we
have.
have another question if you want to take a peek in the chat.
Yeah. I'll finish this note here and then I'll do my best.
Okay, cool.
So I'm in that directory, and then I've got the remote testing directory here, and that's where that README file exists. If I open up that README file, you'll see that level 1 heading, remote_testing. And so that just shows that I was able to take code from GitHub and clone that repository locally to a local repo. All right, so looking at the chat, when is it appropriate to use HTTPS SSH Git CLI? I'll do my best to answer that question, but I would also just throw out right from the get-go that I might not be the best individual to answer the question. The reason for that is I'm a software development engineer level 1 currently, otherwise I'm a junior. I don't have a ton of experience with using the SSH path or Git CLI. I have seen the Git CLI in action. I have used it myself. I just haven't used it a lot. So the Git CLI is probably, I think, the best educated answer that I could give you would be you'd want to use the Git CLI when you're trying to do things within GitHub programmatically. And so when I say programmatically is you can have a script like a PowerShell script or something or a bash script utilize the GitHub CLI commands to automate things like creating a repo or cloning repos or making changes to different code files within a repo or maybe some GitHub actions, right? If you have never heard of GitHub actions, GitHub, another cool thing about GitHub, what they do is they give us a lot of good tools to build some CI/CD pipelines. So you can use the CLI potentially to maybe execute some of those actions, maybe even build those actions, but it provides a programmatic layer, if you will, of access to GitHub. That way, we can have machines kind of take actions on our behalf rather than having us log into GitHub and do things via the UI. What I'll probably do too, I'll take that question. I'll try to get some more info. Maybe we can do like a follow-up post or something on the session as like a um, frequently asked questions or something similar to that. It's a good question. All right. So jumping back into our content, we did the local to remote. And again, you just need to add the remote origin. You need to rename your branch, and then you push that code. Remote to local, the use case here might be you have forked another repository and you want to edit it on your machine, creating a new project, right? So let's say you're in GitHub, you're surfing the web, you find a project you want to contribute to, you might fork that. So if I go back to GitHub here, and I go to any if I wasn't logged in as myself and I was on this repo and it was public, this fork button would be, I'd be able to click this, but I can't because I own the repository. But if you were on this, you'd be able to click this. And what this would do is it would create the repository within your GitHub account. And then following that same process that we just did with the HTTPS, you'd be able to clone this repository locally on your machine. That's the use case that I'm kind of pointing to there. And then to do that, you can use git clone repository URL. If you wanted to as well, you could use that git remote add origin repository URL. And then kind of going back to the question that we heard about or got earlier, you can use that git pull command to pull the code that's in that remote repository locally. If you get an error that says you need some kind of commit in order to do so, that's fine. You can use this this message right here. This allow empty flag will allow you to create an empty initial commit. I wouldn't recommend taking this path if that's the case because you're adding an unnecessary commit to the timeline. But that's one path that you could take if you wanted to. All right, we've got 22 minutes. Let's try to fit this in. Branching. So what are branches? Branches are movable pointers to specific commits within a project's commit history. And I recognize that definition to describe branches because at the end of the day, that's essentially what they are. A branch, you can think of it like a pointer. When you create a new branch, it's and then it's pointing to that commit, that very first commit of that timeline. Then you can add additional commits to that timeline. That's fine. But that's really what a branch is. You can think of it like a movable pointer. It's an isolated environment and code to your heart's content within, without actually modifying or adjusting the original code within, let's say, the shared branch, so to say. One, you can also merge those commit histories back together, provided they have a common ancestor. That's one nuance to there. So when I say a provider, could you have a common ancestor? If you start, but if you're trying to merge one branch that has no common ancestor commit, when I say ancestor commit, like there's got to be one common commit that they share somewhere along the timeline. They need to share that commit in order to say, okay, here's where these two branches originally met up, where they were in sync. They've obviously diverged. They've got all these different commits here. We need to merge these back together. What's changed since the last time that they diverged? Hopefully that makes sense. But at the end of the day, the key takeaway here is that branches are essentially just isolated environments. They allow you to modify code without impacting the code that might exist within a environment or branch that other people are sharing or using actively. A few commands that are useful when creating branches here. You may have already heard of git checkout. There's a new one that was released sometime recently within one of the new versions, but there's another command called git switch. Anytime you see git checkout -b, this -b means that you're creating a new branch. Git checkout branch name, the only difference between these two is that -b flag. -b just means you're creating a new branch. Git checkout branch name means you're checking out a branch that already exists. But you can also use checkout to check out a specific commit hash. When you check out a specific commit hash, this might be a little confusing as well if you've never heard of it before, but when you do that, you are going to be in what's called a detached state, meaning you need to, when you're in a detached state, you need to create commits and then choose a branch to push those back to, because you're kind of operating in limbo, if that makes any sense. So I wouldn't recommend this unless it's on a very case by case basis, but I don't know of any use cases off the top of my head where this would be immediately useful. But it is something to just be mindful of, the differences between checkout and switch. Git switch was introduced by Git to be more specific to branch operations only. And so kind of similar to how checkout, you can create branches, check out branches, but commit hash, it can only be for branches. The -c flag here is to create a new branch, whereas in git switch branch name is just switching to a branch that already exists. So similar to how -b creates a new branch here with checkout, -c creates a new branch with switch. And then anytime you're trying to push your timeline to remote, you can use git push -u origin main. It might not be main, it might be a different branch within the remote that you're trying to push to, but this is one common example. Let's see, finally, the juicy part, what checkout actually means, same as switch, sorry, I got cut quite a bit. So I'll just restate that real quickly. So checkout and switch are a little similar. The biggest difference is that checking out allows you to check out new branches, existing branches, but it also allows you to check out very specific commits. When you check out a specific commit, though, you're going to be in what's called a detached state. In order to fix that, you need to add commits and push those back to a branch. Git switch is more specific to just branching. When you use git switch -c branch name, you're creating a branch. When you do git switch branch name, you're just switching to a branch that already exists, whereas branch name would be the name of the branch that you're switching to. Top averaging, when you want to take code that's in one branch and you want to, lack of a better word, merge it into another branch, it's called merging. There are two different types of merging that I think are really important to know about. You have a fast forward merge, a main branch, and then you use checkout feature. So you do git checkout -b feature. Go back, please. Or git switch -c feature, right? You could use either one of those commands to create the new branch called feature. You add a commit within that branch. You commit that, you can use this tip to actually add a message at the same time, -am. But at the end of the day, you create a commit. You switch back to your main branch. Remember, you were in main here, but you checked out a new branch feature. You switch back to main, and then you use git merge feature. What that's going to do is it's going to take all the commits that you put within feature, and it's going to merge them back into main, but it's not going to create a new commit. The ancestor here is main, right? Because you were in main, you checked out feature, main's going to be the ancestor. So whatever you add within feature, that one shared ancestor commit is always going to exist here in main. One question that might come to mind is what happens if after I check out from main, what if somebody makes a change within main that is not going to get shown within my feature branch because I checked that out before they added the code? Happens all the time. This is where a recursive merge comes into play. A recursive merge occurs when both branches have diverged from their merge base. I don't think I actually talked about the merge base, but this is what I mean by merge base. It's just that common commit. That's their ancestor commit, their merge base. You can think of it as all the same. When this happens, branch Git does some people might call it a three-way merge. Some people call them recursive merge. But really what it's to say is they're taking two branches. I'm trying to merge the code that's within these two branches together. You're obviously merging code from one branch to the other. It takes a look at the ancestor or the ancestry of each commit timeline from each of those, and it detects that it does have an ancestor commit. However, since this person merged from main, main has had some additional commits being made that never made their way to features. So features now kind of out of sync. It's out of date with main. That's okay. But what's going to happen is we're going to have a recursive merge here where it's going to say, okay, you've got the main branch, you've got the feature branch. They have different timelines. I need to find the common ancestor. I need to find all the changes that have occurred since that common ancestor. And then I'm going to take all those changes and make a new commit where basically the code from each branch is pulled together into one brand new commit, and that's added to the timeline on the branch that we're merging to. And you guys will see an example of that here in a second. But I wanted to call that out because it's something really important to know when you're working with merging. If you have questions about rebasing, squashing, come back for the next session. We're going to talk about those. Those are a little bit more advanced. But when we talk about Git commit histories and just taking code from one branch to move to another, merging is often the very first concept or topic that we are introduced to. So I wanted to stay in spirit of that. So before we start with dealing with conflicts, because we're going to see a conflict here shortly when we try to do a recursive merge, but let's go back and start with one of those fast forward merge examples. So I'm going to go over to my VS Code. I'm going to, I think we can just use the same repo that we're in right now. So I'm in remote testing. Let's see where we're at with the status. I don't think we have anything going on right now because we just copied this. Cool. All right. So let's see what branch we're on right now. If I do git branch, you can see that we're on main. Okay. If I do git branch -a is just going to list all my branches. You can see that I have my remotes here, but then I only have my main, which is my local one currently. So if I wanted to do that fast forward merge, what I need to do is I need to check out a new branch first. You guys remember we can do git checkout or git switch. I'll do git checkout -b because it's going to be a new branch. And I'm just going to put feature for now. Let's keep things simple. So if I do git branch, you'll notice that I'm no longer on main, I'm on feature, which is notified by that asterisk and the highlighting here as well. So let's clear the screen. Let's add a few different changes here. So hello, Codecademy. We'll save that. If I do git status, you'll notice that README has been modified, which we expect. And then if you guys remember that tip that I said earlier, we can use git commit -am. This is going to add all of the changes that are in my working area to my staging area, and then provide the message and just create the commit all in one go. So we'll say added hello statement. Sure. Okay. If I do a git log, you'll notice that we have the main initial commit here, but that we also have the added hello statement within the feature branch. So this lives in main, this one lives in feature, right? So if we go back to the example, what we've done so far for this fast forward is we've checked out feature, we've added a new commit. We have not switched back to main yet, though. We have not merged our changes within feature back to main. So let's go ahead and do that and see what happens. Clear my screen here. I'm going to use switch. We're going to go back to main. And I can validate that one of two ways. I can either use git branch just to show that I'm in main. And you can also notice that I don't have that first statement here either. It's gone because that exists in the feature branch, not within the main branch. In order to get that from the feature branch, and while we're in main, is we can do git merge feature. But before I actually do that, what I want to do is show the git log just to show that we only have one commit right here within our log currently. Okay. So if I do git merge feature, we can see that we have that fast forward merge. We have the changes that were in feature. We just merged them to main. They now exist. When I use git log again, you'll just show the two commit. There's not a third commit showing that we needed to take this commit, and merge them together because main never diverged from when feature got checked out originally. The commit was the same. We're only adding the one from feature. So that's a fast switch back to feature. I need to actually type switch correctly though. Git switch feature. Okay. So let's make a few more changes. Hello, Codecademy. I hope this session has been helpful. Let's go ahead and save that. Oh, what are you doing? I think I hit undo. All right. So let's go ahead and save that. We're going to use the same git commit that we had earlier, AM, and then this time we're going to say added helpful statement. And again, I like to keep things pretty basic to help with the learning. If I do a git log, we'll see that we have 3 commits. We'll show that we have, we'll have one commit that's in feature that does not yet exist in main, right? Because we already did the merge to main. So main has the latest commit there. It does not have this added helpful statement though, right? Switching back to main. If I switch back to main, you'll see that we just lost that statement. I'm not going to do a fast forward merge here though, right? Because we want to simulate a conflict. What I'm going to do is I'm going to add a completely different statement. So let's say, have fun with this conflict. I'm going to save that. I'm in main right now. I'm going to use this commit statement. Say, added a conflict. Okay. I'm going to clear my screen. Let's take a look at the log. If I use git log and then I use all, just maybe all, no, -a. All right, so why are you not? Trying to show the commit that we just added within feature, but it's not showing there. Anywho, you guys know it exists. We were just on feature, right? We added that one statement that says, I hope this session's been helpful. We are in main right now, though, where that statement does not exist. However, main has this new statement that says, have fun with this conflict, which we have added as a commit, right? So the key thing to call out here again is that main and feature have diverged. Feature has a commit that main does not have. Main has a commit that feature does not have. That's going to cause a conflict. And this is where a recursive merge comes into play because it notices that these two branches have diverged. They do share an ancestor, but there's code that exists within the branch being merged into that does not exist within the branch being merged from, okay? So in order for us to simulate that conflict here, what we need to do, and I'll just go back here so we can see the commands one more time. We did the fast forward example. We're on the recursive example, right? We've checked out feature. We didn't need to use -b because feature already existed, but we added a commit in feature. We switched back to main. We added a commit within main, and now we're going to try to merge feature, and we're going to see that we have a conflict get brought up. So to see that in action, just make sure I'm still on main. I am. So if I do git merge feature conflict, okay, let's see what's going on. If you're in an IDE, IDEs have really good tools that kind of like help us. This is called a merge editor. Um, it helps us look at the changes that are incoming, the changes that currently exist, and we're allowed to modify this code in order for it to show exactly what we want the code to be. This is how we resolve a conflict. A conflict is essentially saying, hey, I see you're trying to merge merge from one branch to the next. This branch has code that your branch does not. And I need you to tell me what part of that code I need to keep. The computer's not going to make that decision for you. If you have code within different files, that's fine, it's separate. It's when you're targeting changes to the same file from multiple branches that we run into this issue, because we need to determine what code stays, what code doesn't stay. So for example, if I wanted to keep all three of these lines, I could say accept both changes. If I wanted to accept the incoming change is the one coming from the branch that's being merged from, which is feature in this case. If I clicked accept incoming change, it would get rid of the have fun with this conflict and just keep the changes from feature. If I clicked accept current change, which you'll see here, current change is the one that exists in the branch being merged to, which is main in this example, right? So if I wanted to have fun with this conflict and get rid of that code within the feature branch, I could click current change. If I didn't want this conflict, again, I could just click accept incoming change. And what that's going to do is it's going to keep hello Codecademy, but it's going to get rid of that conflict statement. And keep in mind here is that you need to add that change here after you save it, right? So once you do the merge resolve here, you're going to save the file as you want it. Oh, I've got a lot of stuff over here because I have multiple repositories. That's why. We have the README right here. It's in a merge change. And I think we just need to do merge continue. Let's go ahead and apologies, I missed a step. Once you save the changes, you just need to stage them. And then once you stage them, you can do your git merge continue. It's going to ask for a commit message up here. Once you close out of this file, it'll do everything automatically. But if you by default, the statement is just going to say merge branch feature. You could erase this and do something else if you wanted to provide a more thoughtful message, but provide everything will be fine. It'll merge, and you can now tell that we are still within our remote testing. We're in the main branch, and the main branch now has these changes reflected after the conf that I want to call out again. When we said fast forward merging, I highlighted that this does not create a new commit. Recursive merging creates a new commit. And that's the commit that you see right here. You can still see that we had to add helpful statement. You can still see that we added a conflict, but then you have this merge commit that actually makes those changes and takes the code for both of those branches and puts it together. And that was kind of an example of how we deal with conflicts. So conflicts occur during recursive merging when changes are made in different branches, affect the same part of a file, and get it cannot automatically decide which version to keep. Distinct commit histories. If you wanted to practice that a little bit more, all you would need to do is just create a repository, create different branches, create commits within those branches, and then practice merging the code between the branches, especially if those branches have different changes. And then you can get a little bit more experience with how you might handle conflicts. Um, we are at time. So what I will do is I'm going to actually save cherry picking for session 3. That might actually not be a bad idea because cherry picking is another advanced topic when it comes to taking code from one branch to the next. That's really going to be the biggest point of the next session, the third session. We're going to talk about branching a little bit more and commit best practices. But the biggest part of that session is going to be talking more about merging, rebasing, squashing. We'll do some cherry picking as well because we didn't have time today. And then going back to your question, Karen, again, next session we're going to be working with stashes and learning a little bit more about what those are. And then hopefully by the end of this series, kind of like what I highlighted originally, you guys should feel a lot more comfortable and empowered to either work within your own repositories, contribute to a friend's project, contribute to open source projects. I just want you guys to feel a lot more comfortable with Git and GitHub at the end of all this. So thanks for the time today. Hopefully this was a helpful session.
All right. Could we give just right thank you in the chat if you haven't already to Nick for taking his time to put together this fantastic presentation to do part 2 of this workshop. That was awesome. If you have any questions to Nick, you can find him in our community and directly message him, or you can leave a question or comment on the actual event posting in our community. So thank you so much. We are still trying to figure out schedules for part 3, so stay tuned and we will let everyone know who attended today's session, like when that will be. But again, you can always message Nick if you'd like more information. In addition to that, we started live streaming these workshops onto YouTube. And so once we end today's session, it'll be automatically uploaded. So if there's anything that you wanted to rewatch, you're more than welcome to. And we will also share that link as well. And my apologies. I know there were some audio issues with some pauses there, but we'll try to remedy that for the next session. So anyways, thank you again, Nick. Thank you for everyone around the world attending. And I hope y'all have a good rest of the week. Talk to you later.